Hello dear students, this is Dr. Saurabh sir's classes. This is the contact number of our classes which is 98367930076. Again I am repeating the number which is 98367930076. Please feel free to contact on this number so you can enjoy all the opportunities of Dr. Saurabh sir's classes, like one-on-one sessions, like batches. And I am saying that we are eagerly want to tell you that we are organizing a batch for TIFR, NBHM, ISI, CMI entrance preparations. Okay, so for details you have to call on this number, and again, and if you have any mathematical doubts or anything, so please feel free to call on this number. Okay, so now we are solving a TIA for GS previous year question, which is this 2000, which is in this year 2025. So the question is telling us that for a positive integer n, define the function which is fn from r to r by fnx is equals to sine x by n. Consider the sequences which is my fn and fn dash of the functions from r to r. Which of the following statements is correct? Our option A is telling us that the sequences fn and fn dash both converge uniformly on r. Option B is telling us that neither of the sequences converges uniformly on r. Option C is telling us that the sequence fn converges uniformly on R, but the sequence fn dash does not. And our option D is telling us that the sequence fn dash converges uniformly on R, but the sequence fn does not. So what can be done with this thing? Okay. So firstly, we are going to analyze the sequences. So let me, okay, yeah. Now I think it is visible. Okay. So what can I do? That, okay, yeah. If I have to change my color, so I have to, okay. So our fnx is sine x by n. We know that. So after that, what will happen? So we can say that at our n tends to infinity, our x by n goes to 0 for all x belongs to R. Yeah. And after that, what will happen? Sorry. Yeah. So after that, what will happen? So therefore, our fnx will go to sine 0, that is 0, pointwise. So this is pointwise on R. Now we are now check the uniform convergence. So for uniform convergence, we need to see this thing. Supremum of x belongs to R, where our mod of fn x minus 0 is tends to 0 as our n tends to infinity. So now we are going to compute it as our supremum of x belongs to R, and that is my mod of fn x, that is equals to supremum x belongs to R, and it is what? It is sine of x by n mod 1. So this is 1. Since our sine x by n oscillates for large mod x. Okay, so since the supremum does not approach 0, our fn does not converges uniformly on R. So our fn x, sorry, yeah, 1 to infinity does not converges uniformly on R. So now we are going to analyze the derivative thing. Okay. So f dash nx is what? That will be cos x by n into 1 by n. Yeah, n equals to 1 to infinity, and this is n equals to 1 to infinity. Then what will happen? Then we can see that as our n tends to infinity, our x by n goes to 0. Then what will happen? Then our f dash n x will go to 1 by 1 by sorry, that is my 1 by n into 1, so that will be 1 by n, so that is 0 as our n is tending to infinity. Okay, that is fine, but now we have to check the, so this is my pointwise on R. So now we have to check about the uniform convergence. So what can be done? Okay. So what can be done now? So now we again have to think about with the supremum things. So supremum of x, supremum where our x belongs to R, then our f dash in x, the minus 0, so this is this, and supremum of x belongs to R, and for this is my 1 by n cos x by n. Yeah. So we can easily see that our this thing will go to 0, because if our cos of x by n will oscillate or anything, so that does not matter, because our 1 by n is in the outside, so our 1 by n will dominate this, and as our n tends to 0, sorry, n tends to infinity, this whole thing will be 0. So our supremum is 0 here, so we can easily say that this sequence, that means the derivative sequence, which is this n equals to 1 to infinity, converges uniformly on R. Hope you understood, guys. So the correct option of this question is my option D, which is telling us that the derivative sequence is converges uniformly on R, but the fn sequence is not. Okay, so again I am telling that please feel free to contact on this number if you have any doubt or anything. Okay, again I am repeating the number, which is 98367 93076. Okay, thank you.